All right, so get this. We're going deep today, like way deep. We're talking about the Earth's core.
Yeah.
It's funny because a lot of people think of it as just like this, big molten ball of metal just kind of hanging out in the center of our planet. But it turns out it's a lot more dynamic than we ever imagined. And that's what we're going to get into today. So the inspiration for this deep dive is an article titled Earth's Core May Be Changing Shape, and it has scientists puzzled.
You know what I think is so interesting about this is that we're talking about a place that is completely inaccessible.
Yeah.
Right? Like thousands of miles beneath our feet, hotter than the surface of the sun.
Oh, yeah.
Under unimaginable pressure. And yet, scientists are piecing together clues about what's going on down there.
It's like we're trying to solve a crime scene, but from space.
Totally.
Right? Instead of fingerprints, we're talking about things called seismic waves, which are basically these shock waves from earthquakes.
Right, exactly. And just like ultrasound or sonar can create images, scientists use these seismic waves to map out the Earth's interior.
It's really incredible how they can do that.
It is, yeah. And they've noticed something peculiar about how these waves change as they pass through the core.
Oh, yeah.
And it's been kind of a head-scratcher for a while.
Okay, so we have this, underground mystery. We have our scientific detectives, and now we need, a prime suspect.
Right. So there have been, two main theories on the table.
Yeah.
One camp thinks that the core's rotation speed is fluctuating, which would mess with how fast the seismic waves travel.
Okay.
The other camp argues that the shape of the inner core is actually deforming like a ball of Play-Doh, being squeezed, which would also alter those seismic waves.
Right.
This new study suggests that maybe, just maybe, both of these things are happening.
What? Wait a second. So the solid, super dense, metal inner core could be changing shape?
I know.
That sounds a little crazy.
Right. It challenges everything we thought we knew about the core.
Yeah.
But remember, we're talking about extremes of temperature and pressure. Unlike anything on the surface,
Oh, yeah?
these forces could actually be molding the inner core over incredibly long timescales.
So it's not like a sudden earthquake-inducing morphing situation?
No, not at all.
Yeah.
Think more like geological slow motion
Gotcha.
happening over decades or even centuries.
Okay.
This latest study discovered something pretty remarkable. For a long time, the inner core was spinning faster than the rest of the planet.
Oh, wow.
Then around 2010, it seemed to slow down significantly.
Really?
Yeah, and it's not even a consistent slowing either. It seems like it might have paused or even reversed direction at times.
My head is spinning faster than the core right now. Okay, so we've got this shifting speed, possible shape-shifting. How did they even figure all that out? This is not an easy thing to study.
No, it's not. For this study, they analyzed seismic waves from 121 pairs of earthquakes that all originated in the South Sandwich Islands.
Okay.
And were picked up by sensors in Alaska and Canada.
Why so specific with those earthquakes?
Well, think of it like trying to isolate a specific sound in a noisy room by using these earthquake pairs, which occur in the same place and have almost identical wave patterns.
Yeah.
They could filter out the noise and focus on subtle changes in the waves caused by the core.
That's really clever.
Yeah.
So by comparing how these waves changed over time, they noticed something more than just the speed was different.
Right. There were variations between the signals picked up in Alaska and Canada. And those differences point to something else being at work, beyond just the rotation speed.
Okay.
Something that supports the idea of the inner core actually changing shape.
Okay, I am officially hooked on this underground detective story. We've got our clues, our suspects, but what does it all mean? What are the implications of a shape-shifting core? You got to tell me it's not going to cause the planet to implode or something.
Don't worry, no planetary implosions on the horizon.
Okay, good.
But the implications are definitely fascinating, and that's exactly what we'll be exploring in part 2.
All right, I can't wait. All right, so we've established that the Earth's core might be more like a cosmic lava lamp than a solid, unchanging ball of metal, but you left us hanging there with that cliffhanger about the implications of a shape-shifting core. So what could this all mean for us up here at the surface?
Well, first of all, let me assure you, we're not talking about sudden catastrophic events.
Okay, good.
These changes in the core happen on a geological timescale over incredibly long periods.
Okay, that's good, because I was already picturing the ground splitting open and swallowing cities whole. But seriously, could these slow shape-shifting shenanigans have any noticeable effects on the surface world?
That's a question scientists are actively investigating.
Okay.
One area of particular interest is the Earth's magnetic field. It acts as a shield, protecting us from harmful solar radiation. And guess what?
What?
The magnetic field is generated by the movement of liquid iron. In the outer core...
Hold on. So if the outer core's movement is affecting the inner core, and the outer core is responsible for the magnetic field, are we saying that these shifts in the core could eventually mess with our protective shield?
It's a possibility. That can't be ignored.
Oh, wow.
Some scientists speculate that these changes in the core could be linked to those unpredictable jerks in the magnetic field that have been observed.
Jerks. Is that the scientific term?
It is. There's sudden, unpredictable shifts in the magnetic field.
Okay.
Think of it like the field getting a little twitchy, and those twitches can have real consequences for our navigation systems and satellites.
Okay, so now we're talking about something that could actually affect our daily lives?
Exactly.
Wow.
This is why continued research in this area is so important.
Yeah.
The more we understand about these deep Earth processes, the better we can prepare for any potential impacts on the surface, both in the short and long term.
So it's like a domino effect. Shifts in the inner core could trigger changes in the outer core, which could then affect the magnetic field. That protects us.
That's a great way to put it.
Yeah.
And remember, we're talking about a planet that's interconnected in ways we're still just beginning to understand.
You know, back in part 1, we talked about how scientists use seismic waves from specific earthquakes to study the core. Can those same waves tell us anything more about these potential effects on the magnetic field?
They absolutely can.
Okay.
The article mentions that further analysis of these seismic waves could reveal where the convection in the outer core is strongest.
Convection. Remind me what that is again?
Basically, it's the process of heat transfer that drives the movement of that liquid iron. In the outer core, think of a pot of water boiling.
Okay.
The hot water rises, cools, and sinks again, creating a circular flow.
Right.
That's convection.
Okay.
So figuring out where that convection is strongest in the outer core could tell us why the inner core is behaving the way it is.
So it could like help us pinpoint why it's doing what it's doing.
Precisely.
Okay.
It could also help us pinpoint where the inner core might be softer or more susceptible to deformation.
It's softer. I thought we were talking about solid metal.
We are, but even solid metal can deform under immense pressure and heat.
Right.
It's a bit mind-boggling. But imagine taking a piece of steel and squeezing it in a vise for millions of years. It's going to change shape, right?
Okay, yeah. So the inner core isn't perfectly uniform.
Exactly.
Okay.
There could be regions that are more pliable or have different compositions, which would make them more susceptible to the forces exerted by the outer core and mantle.
It's amazing to think that by studying these tiny variations in seismic waves, scientists can piece together a picture of a world we can't even see.
It really is, and it's a testament to human ingenuity and our insatiable curiosity about the world around us, even the parts we can't directly observe.
So we've got a shape-shifting inner core, a swirling outer core, and a magnetic field that's getting a little twitchy. What other surprises could be lurking in the depths of our planet?
Well, that's the beauty of science. There's always more to discover. And in part 3, we'll delve into some of the big picture implications of these findings and explore what the future might hold for our planet's hidden heart.
We've been on quite the journey, haven't we?
We have.
Really, we've gone deep to the heart of our planet. And we found out that the core is this dynamic shifting thing. It's so much more complex than just that static image, that we all had.
That we grew up with.
In our heads. I mean, it's mind-blowing to think about the forces that are at play down there and how they could ripple up to the surface.
It really challenges our perspective,
Totally.
right? We think of the Earth as this solid, unchanging foundation, right, beneath our feet. But the reality is it's a living, breathing system with processes happening on timescales that just dwarf human comprehension.
Yeah, it's almost humbling in a way. But it's also really exciting because we're talking about fundamental forces that shaped our planet. And they're still influencing it today.
Absolutely. And this research really highlights how interconnected everything is. We've talked about the potential for these shifts in the core to affect the Earth's magnetic field, which is so crucial for life as we know it.
You know what? It makes me think about all those science fiction stories about planets losing their magnetic fields and becoming uninhabitable.
Right.
Is that a realistic scenario that we should be worried about?
I mean, it's a good thing we have scientists constantly monitoring these things.
Yeah.
But seriously, while we've learned a lot, there's still so much we don't know about how the core influences the magnetic field.
Earlier we mentioned those magnetic irks
Yes.
that could disrupt our technology.
Yeah.
Are those a sign of something more serious? Or are they just a normal part of the field's fluctuation?
That is the million-dollar question.
Right.
So we know the magnetic field isn't static. It's constantly shifting and changing.
Okay.
There's even evidence that it has completely flipped polarity multiple times in Earth's history.
Really?
Meaning magnetic north and south have switched places.
Wow. So our compasses would point south instead of north.
Exactly.
That is wild.
Yeah, and these flips are not sudden catastrophic events, but they happen over long periods, and they're thought to be linked to changes in the geodynamo, that process in the outer core that generates the magnetic field.
Okay, so while those flips might not be an immediate threat, they could still have a big impact, right?
Definitely.
Yeah.
Think about all of our technology that relies on the magnetic field. Navigation systems, satellites, communication networks. A significant shift in the field could cause major disruptions.
Yeah, it really makes you appreciate the incredible balance of forces that make life on Earth possible.
Absolutely.
Yeah.
It really does, and it underscores the importance of continued research.
For sure.
The more we understand about the Earth's deep interior, the better we'll be able to anticipate and potentially mitigate any negative effects of these changes.
As we wrap up this deep dive, I'm feeling a mix of awe, a little apprehension, but mostly a sense of wonder. It's incredible to think that these processes are happening, thousands of miles beneath our feet, and they could have such profound effects on our lives.
I think that's the perfect takeaway.
Yeah.
It's a reminder that we're all connected to this planet in ways we might not even realize. What happens deep down in the Earth's core can ultimately affect us all.
That's a really powerful thought, and it leaves me with a question for you, our listener. What if these discoveries are just the beginning? What other mysteries are still waiting to be uncovered in the hidden depths of our planet? Keep exploring, keep questioning, and never stop being curious about the world around you. Thanks for joining us on this deep dive, and until next time, keep looking deeper.